Get ready to tackle a new challenge: solving equations with variables on both sides. It's like discovering hidden treasures in a puzzle. Remember those parentheses from earlier? We'll use the distributive property to unlock them and reveal the hidden variables. If you feel a little rusty on the basics, brush up before diving in. A strong foundation is key to success. In this lesson, you will do and learn 3 things. First, you will combine like terms on both sides of the equation. Second, you will learn how to decide which variable term to move and how to move it. Finally, you will solve the equation using inverse operations to isolate the variable. An equation with variables on both sides is a mathematical sentence where the unknown value, which is represented by a variable, appears on both the left and right sides of the equal sign. An equation is like a balanced scale. First, the equal sign is the scale's fulcrum, the balancing point. Second, the expressions on each side of the equal sign are like the weights on the scale. Most importantly, to keep the scale balanced, or the equation true, whatever you do to one side, you must do to the other. Which scale is balanced? Let's use this visual to understand equations better. As we learn to solve equations, think about how this picture represents the concept of balance. This is taken from this lesson's worksheet. You may find it helpful to pause the video and download it. Of course, it is also on the note pages too. Remember, it's your learning, so do what works for you. Now, use the scale to find the value of x. Need a moment to think? Pause the video. Ready? The answer is 10. Let's call it 10 pounds for now. Remember, the goal is to keep the scale balanced. So, if we add 3 pounds to the 10-pound weight, we must also add 3 pounds to the other side to keep it even. Similarly, if we subtract 2 pounds from the unknown weight, x, we must subtract 2 pounds from the 10-pound weight to maintain balance. We can continue adding, subtracting, multiplying, or dividing on both sides as long as we do the same thing to keep the scale, or equation balanced. Alright, let's break this down. So, we've got 2x equals 20. That means 2 times some number, x, gives us 10. Think about it like this: we have 2 mystery bags that together weigh 20 pounds. What does each bag weigh? To figure this out, we need to undo the multiplication. The opposite of multiplication is division, right? So, we divide both sides by 2. 20 divided by 2 is 10. So, each mystery bag, or x, weighs 10 pounds. Okay, let's figure this out together. Why do you think the scale is balanced? Take a minute to think about it by pausing the video. The scale is balanced because we did the same thing to both sides. We moved an equal amount, x, from one side to the other. Now, here's a tricky one: how can we move that x back to the other side? What math operation would undo what we just did? Think about it. To move the x back to the other side, we will add x to both sides. This will give us the original equation of 2x equals 20. Here, you see x being added to both sides of the scales. Since a negative added to positive x is 0, the right side will be left with 20. On the left hand, when add x to another x, we will have 2x, or 2 times x. Remember that multiplication is just repeated addition. Since we added an x to both sides of the equation, we are back where we started. As you can see, this scale is out of balance. Your job is to balance it. Here are the questions you need to ask yourself. First, how many blueberries are there in total? Second, how many blueberries need to be moved? Finally, what variable would make sense to use in place of blueberries? Take a moment to consider it. The next slide shows a balanced scale of blueberries. I chose B to equal blueberries. Granted, variables can be anything, it just makes algebra easier when the variables make sense. There are people who try to be clever by assigning something nonsensical, but that only makes their work harder. Besides, in the real world, you wouldn't do that. If you were selling blueberries, you wouldn't pick V because that would confuse your customers. Notice on the left-hand side, we have 6 Bs, which is fine. On the right side, we have 6B or 6 times B. Either one is fine. I prefer what is written on the right-hand side because it is more manageable as the numbers get larger. Suppose you had a truckload of blueberries. In that case, you may have 100 cases or more. It would make more sense to use the coefficient of 100 than writing out 100 different Bs. Let's break down solving equations with variables on both sides into easy steps. First, check if you need to use the distributive property. Sometimes you will, sometimes you won't. Next, combine like terms on both sides of the equation to simplify things. Now, here's a tip: move the smallest variable term to the other side. This usually makes things easier. Use inverse operations to get that variable alone on one side. Finally, solve the equation like you've done before. You've got this. Let's work through some examples together. Our first step is to distribute. Do you see any numbers outside parentheses? That's your clue. Pause the video if you need time. Let's multiply that number by everything inside the parentheses. For example, if you see 2 times x added to 6, you will multiply 2 by x and 2 by 6. Now that we have multiplied by 2, we need to combine like terms. Pause the video and take a moment to look for like terms. Combine them before moving to the next step. Hint: in this problem, the like terms that need to be combined are on the left-hand side of the equation. I will not always give you that information, but since it is a new skill, I will offer a little help. Let's focus on one side at a time. We combined the 2x and 4x on the left side to get 6x. Now, let's look at the right side of the equation. Can we combine any terms there? Remember, we can only combine like terms. There are no like terms on the right side of the equation. So, we say it is already simplified. Now, we are ready for the next step. Remember, the number in front of a variable is called the coefficient. Take a moment to look at the numbers in front of the excess on both sides of the equation. Pause the video while you do this. We want to move the smaller variable term. Look for the smallest number in front of an x. That's the term we'll move. In this case, that term is 3x. Since we are moving a positive term, we'll subtract it from both sides to keep the equation balanced. So, we will subtract 3x from both sides of the equation. We started with the original problem, and then subtracted 3x from both sides. This is the middle row. Now, look what happened. We've transformed a tricky equation into a familiar two-step equation. In step 5, we will solve it just like we did in the last lesson. We remove the constant and divide by the variable coefficient to solve a two-step equation. So, we subtract 12 from both sides of this equation. This will give us 3 times x, which is equal to negative 27. I know the final answer will be negative, because I am dividing a positive number by a negative number. Finally, I divide negative 27 by 3 to get negative 9. So, my final answer will be expressed as x equals negative 9. How is this problem different from the previous example? We don't need to distribute anything in this problem, so let's move on to the next step. Remember that step. Take a moment to think about it. If you need to, pause the video and review. In step 2, we will combine like terms one side of the equation at a time. On the left side of the equation, we combine a positive 5x and a negative 2x, which gives 3x. Remember, combining a positive and negative number is the same as subtraction. There is nothing to do on the right side of the equation. So, we just rewrite it. We now have a new problem, as seen here. It reads, 3 times x added to 3 is equal to negative 2 added to 12. Do you remember step 3? Take a moment to think about it before proceeding to the next step. In step 3, we determine what variable needs moving. Look at each of these terms and decide the smallest variable coefficient. Take your time. I will be here when you get your answer. You are correct. It is the negative 2x that needs to be moved from the right side of the equation to the left side. To move a negative number, you must add it. So, we will add 2x to the equation's left and right sides. Always remember algebra's golden rule: keep the equation balanced. Do you remember step 4? Take a moment to think about it. Step 4 involves moving the smallest variable found in step 3. As previously mentioned, we will add 2x to both sides of the equation, leaving us with a positive 18 on the right side. When we complete step 4, we will have a two-step equation that reads, 5 times x added to 3 equals 18. This should be a reminder of step 5. Do you remember what it is? We are going to solve this equation. We remove the constant by subtracting 3 from each side. Finally, we divide by the variable coefficient of 5 to get our final answer. Since 18 minus 3 is 15 and 15 divided by 5 is 3, we know x equals positive 3. There you have it. Equations with variables on both sides aren't that bad. I like them because I feel like I am doing quality math that many people struggle with. The independent practice is just like the problems we have worked. Here is a sample problem. You will do great as long as you follow the steps. Remember, step 1 you distribute, if needed. In step 2, combine like terms if needed. In this problem, there are no like terms to combine. Some problems will require it, and some won't. Step 3 is identifying the smallest term. This will be used in step 4 when you use inverse operations to move that term. Finally, in step 5, you will solve a two-step equation. It is just that easy. Let's keep the equation organized as we solve it. Take it one step at a time. First, if there are parentheses, use the distributive property to simplify. Then, turn the equation into a familiar two-step equation that you can easily solve.